Every photograph ever taken from the surface of Venus was taken by the Soviet Union in the 1970s and early 1980s on film, 40 years ago, and we have not been back since. Not the United States, not Europe, not China, not anyone. Because Venus is not a planet you visit. Venus is a planet that destroys what touches it. And for a brief, almost unbelievable moment in history, a series of small spacecraft from a country that no longer exists fell out of the sky onto its surface, opened their lenses, and showed us something no human had ever seen before. A world that should not be photographed at all. Venus is the closest planet to Earth. It is almost the same size, born from the same dust, in the same neighborhood, around the same sun. It should have been our twin. Instead, it became something else entirely.
The surface temperature on Venus reaches about 465 degrees Celsius, close to 870 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure at the ground is roughly 92 times that of Earth's, equivalent to standing nearly a kilometer beneath the ocean. The clouds are not water, they are sulfuric acid. The air is almost pure carbon dioxide, trapping heat in a runaway greenhouse so violent it makes Venus the hottest planet in the solar system, even hotter than Mercury, which sits much closer to the Sun. A human standing on Venus would not last seconds. A spacecraft, designed by some of the best engineers on Earth, can last barely an hour, and the Soviets knew it. They tried anyway, because someone finally was determined to see. It was called Venera, Russian for Venus. It ran from the early 1960s until the mid-1980s. Mission after mission, probe after probe, many of them ending in silence. Some failed at launch. Some burned up in Venus's atmosphere on entry. Some lost contact moments before reaching the ground. In 1966, Venera 3 became the first human-made object ever to touch the surface of another planet and was destroyed before it could send back data. In 1970, Venera 7 became the first spacecraft to soft land on another planet and transmit data from the surface. It lasted 23 minutes on the surface of Venus before going silent. 23 minutes. That was the beginning. Each new probe was tougher than the last. Thicker walls, heavier shielding, better cooling. Engineers were not building spacecraft to explore Venus. They were building spacecraft to survive Venus, just long enough to take a picture before they were melted, crushed, or both. To understand what these probes were doing, you have to understand what they were made of. Each Venera lander was essentially a titanium pressure sphere, sealed against an alien sky. Inside, layers of insulation. Outside, a heat shield burning away during entry. The optics, the very lenses that would take the photographs, were sealed behind thick quartz windows. Some probes used melting metals as a kind of internal heat sponge, substances that absorb heat as they change phase, buying the spacecraft a few extra minutes of life. Every system inside was on a timer. Every camera knew it might only get one chance. This was not engineering for elegance. This was engineering for defiance. In October of 1975, Venera 9 became the first spacecraft in history to send back an image from the surface of another planet. A black and white panorama, grainy, strange, beautiful. It showed flat ground covered in sharp, broken stones, like a quarry under a low orange sky. A horizon so close it felt almost intimate. A landscape that was, somehow, both completely alien and uncomfortably familiar. Venera 10 followed days later, with a second view from a different region. But the most haunting images came in March of 1982 from Venera 13, the first probe to send back color photographs from the surface of Venus. Orange light, yellow rock, dust like a desert at dusk on a planet where dusk never ends. The probe captured the wind, it recorded sound, it analyzed soil chemistry. It survived for 127 minutes, more than twice as long as it was designed to. Venera 14 followed it within days, returning even more color images than nothing. The cameras went dark. The atmosphere did what it always does, and the Soviet Union, in time, was gone too. Those photographs, taken more than 4 decades ago, are still the only photographs humanity has ever taken from the surface of Venus. That is not a historical footnote. That is a fact about right now. It is not that we forgot about Venus. It is that Venus is just that hard. Every probe ever sent to its surface has been killed within hours by some combination of the heat, the pressure, and the chemistry. Modern electronics, the kind we depend on for nearly everything, simply do not survive there. Standard silicon chips fail. Batteries swell and rupture. Lenses fog. Seals warp. Sending a lander to Venus is in many ways harder than sending one to Mars. Mars is cold and thin and quiet. Venus is hot and thick and corrosive. NASA, ESA, and other space agencies have several Venus missions in development, among them Da Vinci, Veritas, and Envision, designed to map the surface from orbit and study the atmosphere as a probe descends through it. But a true, long-lived lander, one that could stand on Venus for days or weeks or longer, would require materials and electronics that, by and large, do not exist yet. So for now, when we want to look at the ground of Venus, we still have to look at images taken before most people watching this were born. And the strangest part is, Venus may not be quite as dead as we once assumed. In recent years, reanalysis of decades-old radar data has shown what looks like signs of active volcanism. Surface features that appear to have changed over time. If confirmed, that would make Venus only the third known volcanically active world in the solar system, alongside Earth and Jupiter's moon Io. In 2020, astronomers reported a possible detection of phosphine, a gas that, on Earth, is associated with biological processes high in Venus's clouds. The result has been heavily debated and is still not confirmed, but the upper atmosphere of Venus, where temperatures are far cooler and pressures much lower, is now being studied seriously as one of the more plausible places in the solar system for unfamiliar chemistry to exist, possibly even, in some form, life. Not on the surface. The surface is too brutal, but somewhere in the clouds. The next time Venus appears in your sky, and it will, brighter than every star, just before sunrise or just after sunset, remember what is happening underneath those clouds. A landscape that has only ever been photographed once by a country that no longer exists, with cameras that died within minutes of opening, a world that swallowed nearly every machine ever sent to it, a world that may still be erupting, a world that may, somewhere in its acid skies, hide something we cannot yet name. For a few short minutes, decades ago, we saw it, and it saw us back.